Okay, for question 2 here. Mr. Lee is a math teacher at Pinkston High School and is preparing students to take the SAT test. He collected data from 10 students who took the test last year and presented the information to the students in the table. The highest math SAT score a student can achieve is 800. Analyze the data in the table. So we're going to start by doing question A, plugging this into their calculator. Remember, this is going to represent L1, and then the other one's going to represent L2, list 2. So let's start by doing part A. Now, you should have already gone in to your stat edit and put that into your calculator. Let me get my finger out of the way. Now, to run the stat plot, we hit second, y equals. Make sure plot 1 is on. If it is not, remember you click enter, and this is where you can change it to off and change it back to on by hitting enter, and then go hit graph. Now, if your window does not automatically start showing the points, remember we hit zoom stat 9, or zoom stat option 9, and this is the data that is being displayed from our table. So there's our scatter plot. Now, describe any patterns we see in this data. It appears to have a linear trend, a linear pattern, that as the number of hours studied increases, so as these hours, this is our x-axis, as the hours increase, what tends to happen to your score? It tends to improve, it tends to go up. Now, question B, I'm not going to worry too much about. I'm going to come back around to that. But what I do want to get into is, then really where we're at is question D, all right? Using graphing technology, determine the regression equation. So scatter plot is where I want you to be, and also calculating the regression equation. Option 4. Those should all stay as is. Let's run it. And as we run that, we get our A and B. Remember the R's we'll talk about next week. So let me go back to my notes, or to the assignment, and jot down 22.54x plus 344.19 as our equation line. So let me get to that. Okay, so I'm answering letter D. We get y equals, or f of x equals 22.54x plus 344.19. Now letter E says interpret the least squares regression equation in terms of the problem situation. So what that means is take what you put for letter D and tell me what does each piece represent. So for letter E, for every increase of 1 hour in studying, the math SAT score will increase by about the slope, by about the 22.54 points. If a student studies 0 hours, which is going to be the y-intercept, their math SAT score, let me write that better. Math SAT score will be 344.19, the y-intercept. Letter F, use the regression line to predict the math SAT score for a student who studied 17 hours, okay? So what we're gonna do then is take our equation we have, 22.54, and let me switch back over to my screen. All right, calculator. So second, quit to go to calculator. We're going to take that equation we created, 22.54x plus 344.19, and we're talking about plugging in 22.54 times the year, or sorry, not the year, well, the hours, which is in this case is, we're talking about 17 hours, plus 344.19, and I get 727.37. Now, what that means here is, let me go back to this. Okay, so when I plug that in, okay, 22.54 times 17 hours of studying, okay. What we can do here is say, how's it phrased? Is this prediction reasonable for this problem situation? Explain your reasoning. The prediction is reasonable and we got 727.37 score. The prediction is reasonable because 17 hours of studying would probably result in a high test score. And when I look at that 17 and kind of look at, okay, here's 14, here's 22, so that's a 700, that's a 780. A 727 would make sense that it is going to be kind of within that range. Now, what we call that is called interpolation, because that is within our data set. If it's outside of the data set, so outside of 22 hours, that's called extrapolation, which is going to be the part for letter G. Letter G is saying, hey, how about for 40 hours? And that would have been then called extrapolation, because it's outside of my data set. So I'm going to do the same thing, but this time I'm going to plug in 40 hours to that equation. So go back to your calculator, type in 22.54 times 40 plus 344.19, and I get an answer of 1,245.79. So is this prediction reasonable? And the thing is, the prediction, it works for our equation, but in the context of this problem, the prediction is not reasonable. And why is that? Because the highest score on the math SAT is only an 800. So you can't get above 800. There is no extra credit then, okay? So that is not possible. You can study for 40 hours, but then the best you might get is still an 800, okay? And letter H, we're running out of room here. All right, that didn't do much for me. So I'll just write letter H right here. One of Mr. Lee's students comes back to him the following year and says that he studied for 15 hours on the math SAT and got a score of 610. He argues that the equation predicted that he would have had a 682. What do you think explains this discrepancy? The equation models trends in data, but may not be an exact predictor for one specific case. So it's probably on the right track. It's just that you won't get anything that specific. There's a lot of other things that would go into that. Okay.